Session 8.3 Testing a claim about a mean. In these sessions, we will learn how to do the hypothesis testing a claim about a population mean when population standard deviation is unknown. We'll be using the t-distribution. For the second part, when we know about the population standard deviation, we'll be using the z-distribution. Okay, so when you guys working on this kind of the questions, with the question carefully, make sure they given the sample standard deviation instead of the population one. Then you have to use the t-distribution. Look at the requirement. Simple random sample. Or the population is normally distributed, or the sample size has to be greater than 30. So this is just like the central limit theorem. Original population has to be normally distributed, or we request the sample size has to be greater than 30. Okay, notation. We have n equal to the sample size, sample mean, x bar, and then we have the mu for the population mean. So this is the formula for you guys find out the test statistic. Okay, the first part we learned we need to know how to find the p-values. Since session 8.2 or 8.1 and 8.2, we learned how to find the p-values of the z-distribution. But since we are working on the t-distribution, that will be totally different. This is the procedure. How you guys using the calculator to find out the p-values? Okay, for example, if you have the left tail test, you'll be finding the t cumulative area from really small number, -1e99, to your test statistic, and then the degree of freedom. And for the white tail test, you're starting with the test statistic with the upper value, 1e99, and then degree of freedom. For the two-tailed test, depends on what is your test statistic. If your test statistic is a positive number, you're going to use this guy. If your test statistic is a negative number, you're going to use this one. But make sure you're going to be multiplied by 2 after you find the area, because you have a two-tail. Okay, let's look at this example. Use technology to find the p-value for the hypothesis test described below. The claim is that the body temperature of healthy adults, the mean is less than 97 Fahrenheit. Sample size n is equal to 10, and the test statistic is given t equal to -1.877. Okay, so we have the claim statement. So we have the original claim, mean less than 97 Fahrenheit. Okay, this is my original claim statement. So first, let's write it down what is the null and alternate hypothesis. Okay, remember the null hypothesis is going to be the mean is always equal to 97 Fahrenheit. And then for alternate hypothesis, it can be strictly less than, strictly greater than, or not equal to. Since my original claim statement here is less than, so I will be using less than in here. So that means this is gonna be the left tail. Okay, strictly less than is gonna be left tail. So we have the pictures looks like this. And then we have the sample size n equal to 10. So we could find out the degree of freedom, n minus 1, which is going to be equal to 9. My test statistic is talking about in this point, t equal to -1.877. Okay, so where is my p-value? my p-value is talking about like here. Okay, p-value is a probability on your left tail in here. So how can we find the p-value? We have the t p-value equal to TCDF. Okay, cumulative area from this point, which is -1e99, to the upper value, which is your test statistic, and then your degree of freedom is going to be equal to 9. Okay, so let's use our calculator here. Go to the second vase. You're gonna choose the TCDF. Okay, the lower value is gonna be -1 E99, comma, -1.877, comma, degree of freedom is 9. Okay, enter. You're gonna get 0.0466. Okay, so if I get like 3 decimal space, that will be 0.047. Okay, so that's our example 1. Okay, example 2. Use a technology to find the p-value for the hypothesis testing described below. The claim is that for a smartphone carrier data speed at airport, the mean is equal to 17. So this is my original claim statement, equal to 17. Write it down the null and alternate hypothesis. So mean equal to 17, and then we don't have the equal for my alternate hypothesis, so we're going to do the opposite. That will be not equal to. And that will be the two-tail test. So sample size is equal to 23. So my degree of freedom, that will be equal to 23 minus 1, which is 22. Okay, so we have the two tails in here. And then I have the test statistic is a positive number, t equal to 1.749. Okay, so the p-value, that will be the area for these two tails. So my p-value, that would be equal to TCDF, starting from this point, 1.749, to the upper value, 1e99, degree of freedom is 22. Make sure you're going to be multiplied by 2, because you have a two tail here. Okay, so let's try. Second vase, TCDF, that'll be 1.749, comma, 1e99, comma, degree of freedom is 22. Okay, and then make sure you multiply by 2 because you have a two tail. So you should get 0.0942. Okay, if we only take 3 decimal space, that will be 0.094. Okay, so this is how you guys find out the p-value using the t-distribution. Okay, now we're gonna write down the step how to do hypothesis testing. So this is test a claim for the population mean, and we the population standard deviation is unknown. Okay, when it says it's unknown here, that means sample standard deviation is given. And make sure you write it down. You will be using the t distribution. T distribution. Okay, first step. Write down the null hypothesis. Alternate hypothesis. It can be less than, greater than, or not equal to. And if there's a less than, that means this is a left tail. Right tail for greater than, and two tail for not equal to. Okay, step 2. Find out the test statistic. You have this formula here. Sample mean minus population mean over standard deviation, sample standard deviation over square root size here. Okay, I want to remind you guys, for this population mean, this population mean, that is exactly same with this guy. Whatever you have this number, plug into here. Okay, and also when you guys using your calculator, make sure you put the parenthesis. Okay, use your calculator, put the parenthesis, sample means minus population mean, divided by and other parenthesis. So this is going to be your step 2. Step 3, find out the p-value. Okay, we just cover from the example 1, example 2. You're going to use the TCDF, the lower value, upper value, and the degree of freedom. Okay, if you have a two-tail, and then you're going to be times 2. And then draw the conclusion. If your p-value is less than or equal to the alpha, you're going to reject the null hypothesis. If your p-value strictly greater than, that will be fail to reject. And then number 4, conclusion. Okay, we will be using this 4 step to do the hypothesis testing for the population mean. Okay, let's try the example 3. In a manual on how to have a number 1 song, it is stated that a song must be no longer than 210 seconds. A simple random sample of 40 current hit songs results in a mean length of 234.6 seconds and a standard deviation of 57.54 seconds. Use a 0.05 significance level to test the claim that the sample is from a population of songs with mean greater than 210 seconds. So first, we have a simple random sample of 40. Okay, this sample size, these 40 current hit songs, result in a mean. This is a sample mean. It's going to be 234.6 seconds. And this standard deviation is talking about these 40 songs. So this is a sample standard deviation. Okay, when you have the sample standard deviation, you need to use the t distribution. First, write down the hypothesis. Remember, every time when you want to write the hypothesis, you have to look at the claim statement. Okay, so the whole paragraph here, which one is gonna be your claim statement? That'll be here, right? Test the claim that the sample is from a population of songs with mean greater than 210 seconds. Okay, so we are working on the population mean, and that's a greater than 210. So we have the null hypothesis, mean equal to 210. And alternate hypothesis, that will be mean greater than. And this is gonna be the whitetail test. Okay, whitetail test. Okay, find the test statistic. We have the formula here. So the sample mean, that will be 234.6 seconds. Remember I said this mean, you could using this mean from your null hypothesis. Okay, this is state that mean, population mean equal to 210. So you could plug in this guy for the 210 here. Okay, plug in here. Try to use your calculator. You should get 2.7. Okay, make sure when you guys using the calculator, put the preference. Put the preference here also. Okay, use a calculator to find and interpret the p-value. So this is gonna be the white tail, right? So test statistic to the upper value and then the degree of freedom. Now we're gonna want to draw the conclusion. Okay, let's draw the conclusion for the p-value. We use the p-value to compare with your significance level. Okay, so this is a less than. So we're gonna be reject the null hypothesis. Okay, final conclusion. And remember we have the table on section 8.1. There's a 1, 2, 3, 4 conclusion. First, the alternate hypothesis is inequality, less than or greater than. So we have to use number 1 or number 2 conclusion. And since we have to reject, so we'll be using the number 1 conclusion. So there is sufficient evidence to support the claim that the sample is from a population of songs with a mean length greater than 210 seconds. Okay. This is how you guys use your calculator to find it out. To find out your test statistic and also your p-value. Okay, you could try it by yourself. Okay, next example. An industry company claims that the mean pH level of the water in a nearby river is 6.8. You randomly select 19 water samples and measure the pH of each. The sample mean and standard deviation are 6.7 and 0.24. Is there enough evidence to reject the company's claims at significance level 0.05? Assume the population is normally distributed. So first, write down the hypothesis. Again, look at the claim statement. Okay, look at these questions. Which sentence is going to be your claim statement? That will be the first sentence here, right? An industry company claims that the mean pH level of the water in a nearby river is 6.8. So first, we're working on the mean, okay? The population parameter with the mean, and is 6.8. So the alternate hypothesis is going to be not equal to, and that will be two-tailed test. Okay, find the test statistic. We have the sample n equal to 19, sample mean 6.7, sample standard deviation. Okay, how about the population mean? Remember, population mean, you're gonna look at the null hypothesis. That would be 6.8, okay? Okay, use your calculator. You should get this one. Okay, you should see my test statistics is going to be negative. So now I will be using this to find the p-value. Okay, so lower value will be negative 1e99, and that will be my upper value because this is a left tail in here. And the degree of freedom. Make sure you multiply by 2 because you have 2 tail. And then you use the p-value to compare with your significance level. So since it's greater than, so we have a fail to reject. And then now we're going to draw the final conclusion. Okay, again, using the table from section 8.1, we have not equal to. So for sure, you'll be using the number 3 and number 4 conclusion. And this is a fail to reject. So you're going to be using the number 4 conclusion. Okay, that is not sufficient evidence to warrant rejection of the claim that the mean pH level of the water in the nearby river is 6.8. Okay, part 2. Testing a claim about population mean when we know about the population standard deviation. Okay, so this time we know about the population standard deviation. We're going to go back to Z distribution. The step is pretty similar. The only thing you need to change is going to be the test statistic and also the p-value. Okay, the p-value. So you'll be using the normal CDF to find out the p-value. Okay, let's try this example. List below are the measured radiation emission corresponding to a sample of cell phones. Use a 0.05 level of significance to test the claim that cell phones has a mean radiation level that is less than 1, okay? And we do have the population standard deviation. So instead of give you the statistic summary, they give you like a list of the data. So you guys know how to use your calculator to find out the sample mean? Right? Or you could just use the calculator, add it all up, divided by the numbers. So you should got this too. And actually, we don't need the sample standard deviation because they're given the population one. Okay? And that's why we'll be using the Z distribution. So first, state the hypothesis. So find out the claim statement. That will be this sentence, right? Cell phones have a mean radiation level that's less than 1. Okay, so this is gonna be my null and alternate hypothesis, and that will be working on left tail, okay? Left tail. And then the test statistic, plug in this guy here. Again, the population mean, you'll be using the null hypothesis, which is the one in here. N equal to 11 because I have 11 data. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So N equal to 11. And then we're gonna find out what is the p-value. Okay, left tail. So normal CDF, the lower value, upper value. That will be the area of the left tail. And interpret. So we use the p-value to compare with your significance level. Okay, so greater than, fail to reject. Okay, conclusion. Again, section 8.1, the table, 1, 2, 3, 4, conclusion. So first, look at the alternate hypothesis. Has to be number 1 and number 2. And fail to reject, that will be number 2 conclusion. Okay, that's it.